Hello and welcome back to Cyber Hero. So here we will discuss hash functions and message digest, and we are continuing the cybersecurity and cryptographic series. Now let's see what we are going to discuss here. First of all, we'll see the introduction part. What are the hash functions and message digests, so on. Then some characteristics, how hash function works, popular hash algorithms, use of hash function. In last words, we'll summarize this video. One thing we are discussing here, it is hash versus encryption. So I will try to clear you that what is the difference between hashing and encryption. So let's begin without wasting more time. If you are new here, please hit that subscribe button. Now, moving to introduction part, hash functions are the mathematical algorithm that takes input data of any sizes, generate fixed sized output called a hash. It is also called a message digest or a fingerprint. So what are the hash functions? These are the algorithms, mathematical algorithm. They took an input of any size of data and generate a fixed size output. This is magic. Input can be of any size and fixed size output. For example, generating an hash for hello, HELLO, it may be 01346 ABC, whatever. That is its hash after hashing. Hash functions are widely used in password storage, digital signatures, file verification, blockchain, data integrity. I have made a dedicated videos on these things for password signatures, so on. If you have not watched these videos, please go and check these videos. What does that mean? So here I will go through and just an overview. Password storage, securely storing user passwords, data integrity, ensuring that data remains unchanged. Blockchain, maintaining immutability in cryptocurrency transactions. File verification, confirming the integrity of file after transfer. Data signature, verifying the authenticity of message. Moving next, some characteristics of cryptographic hash functions. So first one is deterministic. In simple ways, same input, always same output. In simple words, I will make it simple. I will try to keep these things here simple so it will be not confusing. Fixed output size. Fixed output size. Regardless of input size, output remains fixed. Example, SH256 always gives output of 256 bits. Pre-image resistance. Given hash H must be hard to find M such that hash MF is equal to pre-image resistance. Then second pre-image resistance, given message MI, it's a mathematical algorithm. If you want a dedicated video in depth detailation of these things, how it works, please let me know in comment sections. I will go through that and make a dedicated video while working of hash, how it works actually. Second pre-image resistance. Then collision resistance. It should be extremely difficult to find any two different messages with same hash. Avalanche effect. A small change in input directly changes output. What does then, if you will get a question, what is avalanche effect? It's an effect, if small change will be in input, it should drastically change in output. How hash functions works. Here is a diagram. Input, then compression, then modular arithmetic, then final dashboard. How? First bitwise operations, then modular arithmetic, then compression functions, then padding rules. I don't know, just something when we will go some mathematical algorithm, we will try to understand how that works, how it converts. So it's in practical work. If you tell me, if you want to know about these things, please let me know in comment sections. I will go through that and make you clear these things. So now let's see some popular hash algorithms. MD5 output is 128-bit, always fast but broken. Vulnerable to collisions, it's not recommended. SHA-5 output 160 bits. Used in older systems, collision attacks are possible, not recommended. Simple words. SH2 family. SH2 to 4, 256, 384, 5100. Strong and widely used, recommended for modern systems. SHA3 construction very strong and modern, suitable for long-term security. These are the modern SHA3 family. Now say let's some uses of the hash functions. Data integrity, password storage, file and malware detection, blockchain, digital signature. We have discussed it before on the second slide. Now we'll see some key and hash functions. HMAC. I have made a dedicated video on this HMAC. If you didn't watch that video, please go and check that video. HMAC, how it's a hash plus secret key used for. In simple way, I will give an overview here because I have made a dedicated video on through that. Authentication, API security. Authentication means validity, user identity. API security meaning protecting API communication. TLS means securing data in transit. IPC ensuring secure internet protocol. HMAC formula, how HMAC key takes message hash K opad hash K bit message. It is strong resistance to length extension attacks. Now what is a hash collision? A collision happens when hash M1 is equal to hash M2. Collisions are dangerous because they allow file tampering, forget certificates, fake digital signatures. Now the main thing, hashing versus encryption. Some features we will discuss here. Reversible. Is hashing reversible? No, but encryption is yes. Purpose is integrity, confidentiality. Output size is fixed always. It is variable. Key used here? No, but in encryption it is used. Let's summarize this video. Hash functions convert data into fixed size fingerprints. Good hash functions must be collision resistance, deterministic, and irreversible. Use strong algorithm like SHA2 family or 3. Hashes are vital for integrity, digital signatures, passwords, and blockchain. If you learned something new today, please hit that subscribe button. Thank you. Bye bye. Take care. See you in next video.